Section 424.3b of the National Electrical Code states that branch circuits supplying appliances or equipment shall have a rating not less than the load to be served. NEC Section 422.10 provides an exception allowing for branch circuits rated at 15 amps to supply single-phase, 120 volt or 240 volt loads, where the maximum load is not over 12 amps. Now, let's apply these code sections to the situation of a 480 volt single-phase gas-fired heater with ignition controls and a small vent motor drawing approximately 1 amp. The heater and ignition controls draw 1 amp. The small vent motor adds a negligible load, so we can approximate its current draw as 0 amps. Therefore, the total load is 1 amp plus 0 amps, which equals 1 amp. Since the total load of 1 amp is less than the branch circuit rating of 15 amps, it is permissible to install the 480 volt heater on a 15 amp branch circuit. It is important to ensure that all electrical work complies with the latest edition of the National Electrical Code and any applicable local codes. Always consult with a qualified electrician for any electrical installations or modifications. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation. It's regularly updated to reflect new technologies and best practices. Understanding the NEC is crucial for electricians, engineers, and anyone involved in electrical work. Let's delve deeper into the concepts involved. Firstly, the branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. In this case, the 15 amp circuit breaker serves as the overcurrent device. Secondly, the overcurrent protection is essential to prevent damage to the circuit and equipment in case of an overload or short circuit. The 15 amp circuit breaker is designed to trip or disconnect the circuit if the current exceeds 15 amps for a sustained period. Thirdly, the ampacity is the current carrying capacity of a conductor. Conductors must be sized appropriately to handle the expected load without overheating. The NEC provides tables that specify the ampacity of different conductors based on their size, insulation type, and installation conditions. The NEC Table 310.15, formerly 310.16, details this. Fourthly, the voltage drop is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Fifthly, the single-phase power is a type of alternating current, or AC, power distribution in which all the voltages of the supply vary in unison. It is commonly used in residential and light commercial applications. Sixthly, the three-phase power is another type of AC power distribution that uses 3 conductors, each carrying a voltage that is out of phase with the others. Three-phase power is more efficient than single-phase power and is typically used in industrial and commercial applications. Seventhly, the appliances utilization equipment generally other than industrial that is normally built in standardized sizes or types and is installed or connected as a unit to perform one or more functions such as clothes washing, air conditioning, food mixing, deep frying, and so on. Eighthly, the equipment is a general term that includes material, fittings, devices, appliances, luminaires, apparatus, and the like used as a part of, or in connection with, an electrical installation. Ninthly, the continuous load is a load where the maximum current is expected to continue for 3 hours or more. The NEC requires that branch circuits supplying continuous loads be derated to 80% of their rating. For example, a 15 amp branch circuit supplying a continuous load can only be loaded to a maximum of 12 amps. Tenthly, the non-continuous load is a load where the maximum current is not expected to continue for 3 hours or more. Branch circuits supplying non-continuous loads can be loaded to their full rating. Now let's consider some additional factors that may be relevant to the installation of the 480 volt heater. Firstly, the wiring method must comply with the NEC. Common wiring methods include conduit, cable, and wireways. The wiring method must be suitable for the environment in which it is installed. Secondly, the grounding is essential for electrical safety. All electrical equipment must be properly grounded to provide a path for fault current to flow back to the source, which will cause the overcurrent device to trip. Thirdly, the bonding is the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed. Fourthly, the disconnect switch is a switch that is used to disconnect the power to equipment for maintenance or repair. The NEC requires that a disconnect switch be located within sight of the equipment. Fifthly, the overcurrent protection device's location must be readily accessible and not exposed to physical damage. Sixthly, the working space around electrical equipment must provide sufficient space for safe access and maintenance. The NEC specifies minimum working space clearances based on the voltage and configuration of the equipment. Seventhly, the labeling should clearly identify the purpose of each circuit breaker and the equipment it serves. This helps to prevent accidental disconnection of critical circuits. Eighthly, the arc fault circuit interrupters, or SIs, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires a SIs to be installed in certain locations, such as bedrooms. Ninthly, the ground fault circuit interrupters, or GFCIs, are designed to detect ground faults, which are electrical conditions that can cause electric shock. The NEC requires GFCIs to be installed in certain locations, such as bathrooms and kitchens. Tenthly, the surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, which can damage sensitive electronics. The NEC recommends SPD for all electrical installations. 11thly, the conductors must be protected from physical damage. This can be accomplished by using conduit or other protective measures. 12thly, the connections must be made using approved methods. Wire connectors, such as wire nuts, must be properly sized and installed to ensure secure and reliable connection. 13thly, the equipment must be installed in accordance with the manufacturer's instructions. This includes following any specific requirements for mounting, wiring, and grounding. 14thly, the inspection is required for all electrical installations. A qualified electrical inspector will verify that the installation complies with the NEC and any applicable local codes. 15thly, the permits may be required for electrical work. Check with your local jurisdiction to determine whether a permit is required. 16thly, the qualified electrician is licensed and experienced in electrical work. A qualified electrician can ensure that your electrical installation is safe and compliant with the NEC. 17thly, the documentation includes keeping records of all electrical work, including permits, inspections, and wiring diagrams. This documentation can be helpful for future maintenance and troubleshooting. Now, let's talk more about the specific code sections that are relevant to this scenario. Section 424.3b of the NEC, which states that branch circuits supplying appliances or equipment shall have a rating not less than the load to be served, is a fundamental requirement. It ensures that the branch circuit is capable of handling the expected load without overheating or causing a fire. Section 422.10 of the NEC provides an exception allowing for branch circuits rated at 15 amps to supply single-phase, 120 volt or 240 volt loads where the maximum load is not over 12 amps. This exception is intended to allow for the use of smaller branch circuits for appliances that draw a relatively small amount of current. However, it is important to note that this exception only applies to 120 volt or 240 volt loads. In this case, the heater is a 480 volt load, so this exception does not apply. Therefore, the branch circuit must have a rating not less than the load to be served, as required by section 424.3b of the NEC. Since the heater draws 1 amp, a 15 amp branch circuit is sufficient. It is important to consider the potential for future expansion when designing an electrical system. If there is a possibility that additional loads will be added to the branch circuit in the future, it may be prudent to install a larger branch circuit. In addition, it is important to consider the ambient temperature when sizing conductors. The ampacity of conductors decreases as the ambient temperature increases. Therefore, it may be necessary to use larger conductors in high-temperature environments. Furthermore, it is essential to select the appropriate type of overcurrent protection for the branch circuit. Circuit breakers and fuses are the two most common types of overcurrent protection. Circuit breakers are resettable, while fuses must be replaced after they trip. Finally, it is important to remember that the NEC is a minimum standard. It is always a good idea to exceed the NEC requirements when possible to provide an extra margin of safety. Here are a few more details to consider when dealing with a 480-volt heater on a 15-amp circuit. 1. The transformer may be needed to step down the voltage. If the heater requires 480 volts and the available voltage is different, a transformer will be necessary to step down the voltage to the required level. 2. The nameplate information is crucial. Always refer to the heater's nameplate for its exact voltage, current, and wattage requirements. This information is essential for proper circuit sizing and protection. 3. The local amendments to the NEC exist. Be aware that local jurisdictions may have amendments to the NEC that are more stringent than the national code. Always check with your local authorities for specific requirements. 4. The proper lockout-tagout procedures are required. Ensure that proper lockout-tagout procedures are followed when working on any electrical equipment to prevent accidental energization. 5. The qualified personnel only should perform the work. The electrical work should only be performed by qualified and licensed electricians who are familiar with the NEC and local codes. 6. The importance of regular maintenance should be remembered. Regularly inspect and maintain electrical equipment to ensure its safe and reliable operation. 7. The infrared thermography can be used to detect hotspots in electrical panels and equipment. This can help to identify potential problems before they lead to failures. 8. The power quality monitoring can be used to identify voltage fluctuations and other power quality issues that can affect the performance of electrical equipment. 9. The energy efficiency can be improved by using energy-efficient heaters and controls. This can save money on energy bills and reduce the environmental impact. 10. The renewable energy sources, such as solar panels, can be used to power heaters. This can further reduce the environmental impact and save money on energy bills. 11. The power factor correction can improve the efficiency of electrical systems by reducing the amount of reactive power. 12. The harmonic mitigation can reduce the amount of harmonic distortion in electrical systems. Harmonic distortion can cause problems with electrical equipment and can increase energy losses. 13. The emergency power systems are essential for critical applications where power outages can have serious consequences. 14. The uninterruptible power supplies, or UPSs, can provide backup power for short periods of time in the event of a power outage. 15. The transfer switches are used to transfer power from the utility grid to an emergency power source. 16. The generators can provide backup power for extended periods of time in the event of a power outage. 17. The grounding electrode system should be installed properly. The grounding electrode system provides a path for fault current to flow back to the source, which will cause the overcurrent device to trip. 18. The surge arresters protect electrical equipment from voltage surges caused by lightning or other events. 19. The transient voltage surge suppressors, or TVSS, are similar to surge arresters, but they are typically used to protect sensitive electronic equipment. 20. The harmonics are unwanted frequencies in the electrical system that can cause equipment to overheat and fail. 21. The power factor is a measure of how efficiently electrical power is being used. A low power factor can result in higher energy bills. 22. The demand factor is the ratio of the maximum demand of a system to the total connected load of the system. 23. The diversity factor is the ratio of the sum of the individual maximum demands of the various parts of a system to the maximum demand of the whole system. 24. The utilization factor is the ratio of the maximum demand of a system to the rated capacity of the system. These factors are essential for properly sizing electrical equipment and systems. In conclusion, always prioritize safety when working with electricity. Ensure that all electrical work is performed by qualified personnel and complies with the NEC and local codes. By following these guidelines, you can ensure the safe and reliable operation of your electrical systems.